This is the final video. I think this is part 5 of this unit that we rebuilt, retrofitted, made for a customer. We had to do a few little minor changes after the last video. This is the next day. I had to take a break from it and work on some other stuff because it took me quite a while and stuff. So if you've never seen the first 4 videos, they're each about 25-30 minutes long or so. We had to take a unit called a PEL 609. Here's the top cover of it, PEL 609. Now there are links in the description below, part 1 through 4. So if you haven't seen those, it's quite a task to do this. Anyways, the reason why we did it, if you're not aware, is the PEL unit, the way it was designed, it's like a 35-year-old unit, give or take. And here's the base of the unit. The cover went all right on top, and all the guts and everything went on top of this thing. Well, anyways, the unit worked like a dream, minus the transformer, which is encased in this big block of epoxy, solid as a rock, is built into the base of this unit, so you cannot get that transformer out. And of course, you cannot buy, one of these anymore. They're obsolete. They've been discontinued and phased out for a couple of decades, probably. But anyways, been a while. But anyways, we had to come up with another option of a transformer since we couldn't, find one because they're not made anymore. And so I talked to the customer, and before I called them, I was trying to find, I didn't know what kind of case we could get out there to fit all this stuff in there, because I knew it was going to take a little bit of room to take all that guts and put it into things. So I just kind of guessed at a size, and I found a couple, 3 or 4 different options online. And so I called the guy up, got the prices in my head. I added about $10 to the price of these things to try to help keep the cost down, because anybody can buy these cases. These aren't like anything special, So these are indoor outdoor plastic cases. This one has a door on the front that you can latch shut here at these little latches, and you can also put a padlock on there, I guess, if you wanted to as well. But they had them with the clear see-through front cover, and they had them with the solid. He's like, don't put the see-through. I want it to, leave it with the solid one, so that way people can't see inside, I guess. Or it would discolor on the, yellow or anything from being outside in the weather. But he wanted one that he could mount outside if you wanted to, or leave it, inside if you wanted to. And this one has a couple different mounting options. Has screws in each of the corners. You can mount it to a wood post or a wall, or side of the building or whatever. And then also has these, if you don't want to do that, it has these 2 big, like 8-inch hose clamps that you loosen up. You thread through there's a little spot here at the back. You thread it through here, and there's the same thing on the bottom. You thread it through. After you unloosen and take the hose clamps apart, you thread it through, and you put it kind of halfway back together, slide it down the post, and snug it up, and it bites down and holds on to the post that you mount it to. So yeah, that would be awesome. So we gave him a price, and he was thrilled, because after testing this unit, it's about a 10 joule unit, so it packs a pretty good wall. This is kind of an old school 10 joule unit. This thing's like 30-something years old, and I believe it has almost all the original parts from it, because nothing in there looked like it had been replaced or tinkered on. I think maybe the board had been worked on at some point in time, at least the main power board did. We had to come up with a transformer that would put out decent amount of voltage and be able to handle that kind of power output that we're trying to achieve and handle coming through it. So I did 2 different things. Transformer-wise, I used one transformer from Power Wizard, which it indeed would work, but the max voltage we could get at was about 4.5 to 5 kV, is about all we could get voltage-wise out of it, which doesn't sound like a lot compared to some of the other brands that are out there, because most brands kind of float between 6,000 9,000 volts on average, some a little higher, some a little lower. But the voltage isn't really the key thing, because the joules is what actually shocks the animal. That's the punch behind the shock. So I was like, well, that ain't gonna work. I mean, it's gonna work, but I want something a little higher voltage. So I was like, well, let me try something else. So I grabbed a Gallagher transformer from another model, one that was of equal type of load capacity it could handle. This one kicked up a little higher, we're closer to 6, 5.5, 6. kV, which is, I was hoping to get 7, somewhere in that range, but I couldn't find one that would, with the winding setup and where this voltage coming into the transformer, whatever it equaled out to be. I couldn't get to, voltage. I couldn't get it to climb that high, so we were just stuck at what it was. But even though it's like 5.5, 6 kV, when we load it down at like 100 ohm, it only drops to like 4 or 3.5, 4 kV. So it only loses like 1500 volts between the max voltage and a very, very heavily loaded voltage, and we're at like 10, almost like 9.8 joule output at like little less than 4,000 volts, and it peaked out about 5.5 to 6. So we only lost 1,000 to 1,500 volts, which sounds like a lot, but it ain't that much from the grand scheme of things. So even though it peaks out lower than some other units, the loss across the board on the load that we hooked up to it was very small, because there's some brands and models you'll peak out at about 8,000-9,000 volts, but as you increase the load across it, it might go from 8,000 or 9,000 volts, and by the time you put a heavy enough load on there, it might drop down to 4,000, 5,000 volts, 3,000 volts. So it might lose 3,000 or 4,000 volts from the peak voltage to the heavily or more on the heavily loaded side, depending on the joule rated that the unit is. But so for in the grand scheme of things, voltage is a little lower than some other ones, but it has the punch power to compensate and get the power to the fence as you need it. So I wasn't too worried about that. The customer's aware of it, and he's like, "No, that's fine. If you say it's good, I'm good." So yeah. So as long as you're over 4,000 volts on the fence, that's about minimum. You start falling below 4 or below 3.5, the joule starts to fall off. As long as you're over 4,000 volts or higher, the joules will always be there, no matter what brand it is. And I can prove that with my meter that I use. Right here, this Energizer performance meter, this tells me the voltage and joule output of a unit based on the different loads hooked up to it. And so I prove that to myself, and anybody who wants to argue with me, well, I like my charger being 8,000 volts. Well, that's fine. Whether it's 5,000 or 8,000, the joules are still going to be there. The voltage is really irrelevant as long as the unit's working internally like it's supposed to. As long as you're 4,000 volts or higher, the joules will always be there, because I can prove it with this meter right here. I can see it like 4.2 kV, you're still getting 8 joules output at, like, if it's at 7,000 volts, you might only be using like 3,000 or 3 joules. So as the load increases, the joules will climb up, put more at the fence as it needs to, based on the load it is, as long as the voltage is over 4,000 volts. So the voltage is important. You need to have it there, but the higher voltage doesn't mean it's stronger. It just means that there's under less stress on the fence. The unit's not working as hard. So don't always be super, super concerned. Oh shit, I was at 9,000, now I'm at 5,000. Oh shit, oh my god. No, it doesn't matter. Don't, you want higher voltage on there, because it means the unit's working harder when there's lower voltage on there. But as long as it's over 4,000 volts and higher, the joules will be there to shock the animal like you want it to. And like I said, I can prove it day and night, anytime I want, by this meter right here. So I don't lose any sleep over that stuff. I don't freak out over it. So, all right. So here's the layout of the thing. I have to ramble there for a while. This is our main power board. All the electronics, the components are on the flip side of it, because the way I had to mount it was like this, because all the solder joints that are on here, there's a strip on the front side, but there's like a coating on there. I scraped and scratched on there. I could not get the solder to stick. So on the back side, where there's already solder at, I was able to fresh up the solder and hardwire and solder all the wires to it like I wanted to. So that's what we did on everything. This is the multiplier board. Over here's what grabs and builds the charge up. This is what does all the timing and discharging and all that stuff with the capacitor. This just built the power up to that board for these capacitors. Here's our main output transformer that spikes the voltage up through the primary over here to the secondary over here. And put his knob down here at the bottom. He's drilled some holes, and I actually reused his factory or his knobs off his other unit. I just drilled holes and put them right here at the bottom. You got red for fence and green for ground, I even labeled on the front. They'll probably put some label on the bottom. I've got the ground symbol there and the fence, lightning bolt symbol, which is most brands put on there. I'll probably write on the bottom here, the in case this ever wears off, I can put down, F for fence and G for ground or something like that. And then here's the side here. We reused his 2 fuse mounts. We got that all wired in there, and I used I actually originally just drilled a hole and just ran the cord. I was like, I'll just fill it up on the inside or outside with some of this this glue stuff, which I actually put another LED on there trying to get a flashing light with a thing, but it wasn't working out. But this light right here is just it's 110 volt abled LED. There's some kind of built-in resistor in there, so we put that right across the top side of the fuses right here with these 2 little wires. So when he plugs it in, that light comes on. It's just on steady. It just tells you, hey, the power's on. I thought about putting a switch on there so you can flip the switch on and off, but most people just plug it in. It's 110, 120 volt, which we're just using this factory cord off this other unit, so because the cord was in good shape. So I put it down low down here because this is going to be mounted on the wall. So I thought about putting it over here because the AC needs to travel all the way over this board here. Like, well, the shortest path to it would be up here. Well, then he loses about this much, cord, because it's got way up here. I'll travel all the way down here and then further down or wherever to go to his outlet. So I just put it down low on the side here, so that way it wouldn't travel and have to travel so far to plug it into the wall. And then I just hardwired it down here, soldered it to there. I kept the gap not super close, but not super far apart, because this is kind of a lightning spark gap, is what they use that as inside there. So I'm gonna see if I can see if I can bend those up at all. Those are pretty tight fitting right there, but I thought if I could bend those up a little bit, maybe we could. No, let's leave them alone. They're fine. It's not going to hurt anything. And then I use these things right here. I didn't use these cheap zip ties. I use stainless steel cable ties. A ratcheting tool that cinches them down and cuts them at the same time. But I put these in there, and I put some screws that came with it. Screwed that down. The capacitors are sitting on top. But these things, 2 on each one. One up here, one down here, on each side. And that's what allows me to run those stainless steel cable ties through it. And that's what's holding this capacitors to the case and everything. With it being stainless steel, we don't have to worry about them rusting or breaking because it's stainless steel metal. So, but I put a lot of time and effort in this thing, and it probably would have gone faster if I ever had to do it again. It could probably go a little bit quicker because I was explaining and kind of learning on the fly as I was doing it. I did have to write down a cheat sheet for the multiplier board, which is what that board is. That's what I called it. And the main power board is what I called that one. I labeled that one that. And then I numbered each of these solder joints. Before I even kind of started, I put down 1 through 4, so I knew that, and 1 through 5 down here on both the front side and the back side, because I didn't know which way I was going to go, and I didn't want to forget. And I put down the original wiring, for everything. PB stood for power board, so pin number 1 or spot number 1 on the multiplier board went to spot number 1 on the power board. So went from here over here. So this is 1 through 5 that way, 1 through 4 that way. And so that's what we had to do there. So unit works like a dream. It's a very slick unit, old school design. I love the thing. I wish I wish manufacturers out there would build boards and units like this, but about only 2 companies kind of sort of do it semi old school, and that would be some of the Cyclop models and some of the Parmax stuff, even though the Parmax got some digital mumbo jumbo things with some of their units. A lot of brands have all gone to the surface mounted technology, SMT they call it, and that's been going on for 20 years. It's nothing new, so it's this is the way of the world. Doesn't mean it's good or bad, just means it's what they do. And cheaper to manufacture and produce a lot more. You can have a robot chicken peck those things on there real quick. You can build probably 10 boards in the time it took a machine or a person to build 2 or 3 of these boards. So, and then you got to assemble the unit. So the only thing I did, because I wanted to make sure that these things did not come out, was I put some of this, what I use? Oh, what? It's that Flex Glue. You see that goofy guy on TV selling that Flex Seal stuff? I use this Flex Glue. Comes in a big tube. It's like $15 for this thing, but you know, I've had this for like a year. I've used probably a little over half the tube, maybe a little less than that. But it never goes bad in the tube. Everything didn't harden up before you're ready to use it next time, but it's tacky. It sticks to everything, and you give it about a full 24 hours, it turns into like a rock, and so it just like using like epoxy, but it doesn't run everywhere. So I like the stuff. I can squirt it out and just where we got to put it at. But I put a bead of it here, which I just put that on just a little bit ago. Put it there and there, just so that way those washers, those nuts that are screwed onto the back side of the two fuse holders don't accidentally loosen up. So I tighten up pretty tight, and I put a bit of it on top of the back side of the nut that's holding the little, you know, what they call it. It's like a grommet or whatever it is that holds that cord in place. Plus, that inside that cord deal, when you tighten it up, has a rubbery gasket type of thing. As you tighten it down, it kind of scrunches down and fattens up. And around this, that cord cannot pull out unless you really pull on it. But you may probably be breaking something before that happened. But man, this thing works like a dream. We'll go ahead and we'll plug it in real quick. And it's my outlet here. Here I go. 1, 2, 3. Let's see, clicking along. There's a little red light powered on. See, as soon as you put power to it, turns on. Last little minute pulse come through. No. Just a power light, tell you, hey, power's on. But let's put a screwdriver, let's put it down here. We'll turn the lights off real quick so you're going to see that spark this thing through. And there's enough room inside here that that shouldn't overheat. These things don't get that hot anyways. So enough air, enough room here for things to breathe. I am going to plug up the holes where these metal bands went through and plug it up from the back so little bugs ants or wasps can't get in there and make their homes. There are little slots down here at the bottom, so the guy's going to have to decide where he wants to tape those off or plug them up. So I would be worried about bugs getting in there, but these things are waterproof. There is a seal that runs around the right around here that meets up with the edge of the case. But I'd still be, it says waterproof, whatever, it's like IP68 or something like that, so it does have some waterproof capability to it. But I would just be worried, so I'm going to leave those things open, and so if water does get inside, it should just run right down and fall out the thing. So we'll just put a screwdriver right down here. Put this camera back up here. Let's see, I need another screwdriver. Oh, hell of a spark. Trying to get the gap just right so I can get the thing sparked. There we go. So I don't know how well the camera picked it up. The gap's only like this far apart. It's like, oh, my old one used to shoot a spark 2 inches. But you see how thick that spark was? It may have only been about that long. That gap might have been only about like that. But the actual thickness of the spark itself was probably 10 times thicker than like a spark plug would spark. So, but yeah, it's a good old unit. Glad I was able to fix it, and yeah, it took me a bit of time to do the whole repair. Most of it was just me kind of figuring it out, and I didn't charge by the hour on this deal. I just kind of wrote a flat price to do the whole thing, with the price of this, I added, like I said, whatever I paid for, I added $10 to it, just so I can cover the cost of the thing. I didn't want to mark it up too much because this wasn't nothing like I had to order wholesale where I just bought it online like anybody could. So I added $10 to this. I don't remember. I charged them for the transformer, and then I charged him a handful of labor to do it, and he was thrilled because a replacement model of equal reliability would cost the guy probably in a 10 joule output unit of equal quality. Oh, you're looking $500 to $800 for something of equal quality of stuff. I mean, yeah, probably between $500 and $800, depending on what brand you went with. I would say a Cyclops Super or a Brute, maybe, or you go to a Gallagher MM1500. Something like that, to like 11 joule output. That's $700 and some odd dollars for that thing. So it was maybe a little more than half price of maybe of a Super Cyclops to do the whole thing, and the guy was thrilled because 90% of that unit was perfectly fine. There's nothing wrong with it. It was just a bad transformer. The board, capacitors, everything was perfect with the thing. So I was glad to help the guy out. It was fun. It took a little longer than I thought it was going to take to do it, but I enjoyed it. So, anyways, there it is for you. So, if you haven't checked out the videos on how we did this thing, I'll put links down below for part 1, 2, 3, and 4, so you can kind of watch the process a little bit from start to finish on how we took the old one apart and pieced it together and started working our way through the thing and how I wanted to do it. I had to do things a couple, 2, 3 different times because I had the board kind of mounted one way, like, nope, that ain't going to work. So I flipped it over, I had to do it again. So luckily, it was only kind of a few holes we had to re-drill once. And then I, like I said, did have a couple LEDs sitting here. I tried one that didn't work. Had to drill a different hole because it was too big. Put another LED right there, a different type. Wired into the old one. And it just didn't work. It wasn't working right. So something with the board, however, that power feeds that LED is wrong for whatever LED I put in there. Or something was different with it. So I tried to reversing the leads around, thinking maybe I was wrong. I got the polarity backwards on the LED, and that didn't change at all either. But then when I went and tested the LED on its own, worked fine. It wouldn't work with the board for whatever reason. It wouldn't power the LED up. So I was like, well, what the hell? It doesn't matter anyways. Just a light. So, anyways, thanks for checking us out on YouTube, and if you like this kind of stuff, hit me up. Send things to us for repair. There's our information right there. Until next time, see you guys later on.